Okay, so we're going to look today at vector multiplication. We'd already looked at vector addition, even vector subtraction, and all the applications of those. There are more applications, so we do vector multiplication. So the first thing we need to understand is there's actually two types of vector multiplication. So there's not a single way to multiply vectors. You can either take the dot product or the cross product. The results, of course, are different, but where and when you use the cross product versus the dot product is what we need to eventually learn. So there's two different types of vector multiplication. That's the first thing we need to get clear. Dot product, we use this notation right here, u dot v. So u dot v. What's important is that the result when you do this multiplication is a scalar. What that means is your answer is a number. So if I ask you to do the dot product on two vectors, your answer is only a magnitude. So we'll be using those particular ones where we're only interested in how big the multiplication is and not necessarily a direction or a new vector. The second type of multiplication is cross product, and we use this little notation. So it looks like the multiplication symbol, but it's an X. It means the cross product. And the difference here is the result is a vector. So when I get a chance to see you again, we'll make sure that we have tried understanding the difference between what type of answers you're going to get when you take this dot product and the cross product. Usually we do that together. So we'll make sure to make a point of doing that if you haven't already. But what we're going to do today is just look at the one example and do the dot product. Next day we'll do the cross product. So today I can tell you that the dot product is found by taking the magnitude of u, multiplying it by the magnitude of v, times the cosine of theta, where theta is the angle in between those two vectors. This will look very similar to projections, and that's not a coincidence. It does come from projections, but really what we need to do is recognize that this is how we calculate the dot product. We'll do some more exercises later on to find out where this comes from, but for now we're just using this concept that the u dot v is the magnitude of u times the magnitude of v cos the angle in between them. So we'll move on to an example. So here we have two vectors, vector u and vector v, and an angle in between them. We could draw this if we wanted, but it's not necessary because all I'm doing is calculating the product, the dot product. So I just need to know how big it is. So if I use the formula, so u dot v is equal to the magnitude of u times the magnitude of v cos theta. In this particular example, the magnitude of u is 4, the magnitude of v is 6, and the angle between them is 154 degrees. When we go to our calculator then, again making sure we're in degrees, I would do the cos of 154 first, get that answer on my calculator, multiply it by 6, multiply it by 4, and we get an answer of negative 21.6. And that is the multiplication here. Now, you might see that the answer is negative, which is fine, and it does have something to do with the picture. If I did draw these vectors, so here's vector u, let's say it's 4, and vector v is 6, and the angle between them is 154. If you remember our note on projections, if we projected one down onto the other, we actually ended up with a vector in the opposite direction. So I'm not surprised that the magnitude of this multiplication is negative, because there is some connections between dot product and projections. But really, all we care about is just calculating the dot product. So the picture is not necessary. We can just look at it, use the formula, u dot magnitude of u times magnitude of v cos theta, and we get our answer. Of course, I can ask a little bit more creative and say a question and say, Here is the answer to the dot product. A dot B is 250. The magnitude of A is 15 and the magnitude of B is 20. So tell me the angle between them. So if I use the same formula, A dot B equals the magnitude of A times the magnitude of B cos theta. Fill in my knowns and unknowns. So in this case, A dot V, it turns out, apparently is 250. A is 15, B is 20. All I'll need to do is rearrange and solve for theta. So 250, 15 times 20 is 300, cos theta. I want cos theta by itself, so I'll have to divide by 300. Get some decimal, push second function cosine. I'm not going to babysit you through this. There's a couple lines in between there, but we get 33.6 degrees. So it turns out the angle between these two is 33.6 degrees.